Imagine the world 4,000 years ago. No glowing cities, no bright screens, no light pollution at all. Just pure ancient darkness. Above you stretches the ultimate widescreen display. The pristine, unpolluted night sky, revealing a vast, glowing ocean of cosmic wonders spanning the horizon. According to NASA, under a truly dark sky, a human can observe over 9,000 individual stars with the naked eye. It is a stunning scientific fact. For ancient humans, this blazing, overwhelming canvas of cosmic light was beautiful, mysterious, and a deeply humbling daily experience. They felt completely connected to the cosmos, but the celestial sphere was not just a peaceful picture. To them, it seemed like an unpredictable realm, governed by powerful forces. Every movement meant something important. Imagine going about your daily chores when suddenly a massive dark shadow begins to swallow the brilliant sun. The light fades into a strange, eerie twilight. The temperature rapidly drops. The wind changes direction. Even the birds go completely silent in the middle of the afternoon. The natural world pauses in awe. Without modern astrophysics, a total solar eclipse looked like an apocalyptic event. It was a profound, life-altering experience for early civilization. A true cosmic spectacle. But instead of just looking away, early humans did something extraordinary. They watched carefully. They remembered. They passed the stories down. Data collection had begun. Slowly they realized that the chaotic sky actually possessed a hidden rhythm. A magnificent cosmic clockwork moving silently above their heads. Patterns began to emerge over time. They noticed the sun rising in slightly different positions along the horizon throughout the year, perfectly predicting the changing seasons. Winter and summer were mapped. They observed specific constellations returning to the exact same spot in the sky right before the vital harvest time. The stars became an agricultural calendar. This realization was the true birth of naked eye astronomy. It became humanity's very first global, multi-generational scientific enterprise. A legacy built across thousands of years. It required no telescopes, no glass lenses, and no electricity. The only tools they had were pure observation, geometry, and immense patience. Their minds were the computers, and to track this majestic cosmic clockwork accurately, our ancestors decided to build massive, permanent observation instruments out of solid stone. They literally moved mountains to read the stars. To understand the sheer dedication of ancient astronomers, let's travel to prehistoric Britain, around 5,000 years ago, to the legendary Stonehenge. The builders dragged these massive sarsen stones, weighing up to 25 tons each, across miles of rugged terrain, without any modern machinery or wheels. But why? For a long time, researchers hypothesized it was purely a ceremonial burial ground or a mystical temple. But it is actually much more. Stonehenge is actually a colossal, high-precision astronomical instrument. It is essentially a prehistoric solar computer, permanently locked into the landscape. The most famous feature is its precise orientation. On the summer solstice, the absolute longest day of the year, the monument comes alive. The first rays of sunlight shoot directly over the outer heel stone, piercing perfectly through the central monument like a golden cosmic laser beam. And it works in reverse. On the winter solstice, the sunset aligns flawlessly with the opposite side, marking the exact turning point of the year. For a prehistoric farming community, this wasn't just neat trivia. Knowing exactly when winter peaked was absolutely essential for survival and managing their food supply. What is truly astonishing is the sheer mathematical precision. The builders had to calculate the sun's exact trajectory using nothing but wooden stakes and ropes. Some researchers propose they even used a standardized unit of measurement across Britain called the megalithic yard to perfectly map the vast circular perimeter. Surrounding the main stones is a ring of 56 pits known as the Aubrey holes. Their exact purpose remains a fascinating scientific hypothesis today. Some astronomers argue these specific pits were used to track the complex cycles of the moon, potentially allowing them to predict those terrifying solar eclipses. By manually moving a physical wooden marker one hole each year, They could track the lunar nodes. It was a massive, physical, analog tracking system. Just think about that. Without a written language, ancient humans built a megalithic structure that successfully modeled the orbital mechanics of our solar system. But giant stone circles are terrible for traveling. What if you needed to carry the cosmos in your pocket? Well, the Bronze Age had an answer. Around 1600 BCE, someone in Central Europe solved the portability problem. They forged the Nebra Sky Disc, the world's oldest known map of the cosmos. To a Bronze Age human, this wasn't just a pretty piece of art. This was the ultimate high-tech gadget. It was essentially a prehistoric smartphone with a cosmic GPS. The disc is crafted from bronze, perfectly inlaid with 32 distinct gold stars. But these aren't just placed randomly to look beautiful. A specific cluster of 7 dots represents the Pleiades. In ancient times, the visibility of this star cluster was the universal signal to begin planting or harvesting crops. It also features a large full moon and a crescent. Archaeologists believe this disk was used to calculate the complex synchronization between the solar year and the lunar calendar. But here is the most mind-blowing part. Look at the golden arcs on the sides. If you measure the angle of these arcs, they span exactly 82 degrees. 82 degrees is precisely the angle between the sunrise on the summer solstice and the sunrise on the winter solstice at the exact latitude of central Germany. This means the Nebra Sky Disc is literally a portable Stonehenge. You could stand on a hill, align the disc with the horizon, and instantly read the cosmic calendar. At the bottom sits a mysterious golden ark, the sunboat. Ancient people believed a magical ship carried the sun across the dark ocean of the night sky. It's a beautiful artifact where hard mathematical precision perfectly merges with deep human mythology. Science and art weren't separate yet. They were one and the same. But eventually, for reasons we still don't fully understand, this masterpiece of early astronomy was buried in the ground as an offering, lost to time for millennia. While the people of Europe were building megaliths and forging bronze maps, another civilization was taking a drastically different approach. An approach that would change everything. Welcome to ancient Mesopotamia. Here, astronomers didn't rely on massive stones. They used something far more powerful and far more scalable. Mathematics written on clay. The Babylonians were obsessive record keepers. From the tops of their ziggurats, priest astronomers recorded the exact positions of the planets every single night for centuries. They transformed the chaotic sky into a giant, living spreadsheet of data. And in doing so, they unlocked secrets of the universe that we still use today. Today, we use a base 10 number system, likely because we have 10 fingers. But for advanced astronomy, base 10 is actually quite clunky. The Babylonians invented a much superior system, sexagesimal, or base 60. And they did it using the exact same hands we have. If you use your thumb to count the 3 joints on each of your 4 fingers, you get 12. Multiply that by the 5 fingers on your other hand, and you get 60. Why is 60 so special? Because it is a highly composite number. It can be divided perfectly by 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30. This made complex fractions a breeze without decimals. And when the Babylonians looked at the sky, they noticed the sun takes roughly 360 days to complete its cycle. 360 is just 6 times 60. So they mapped the sky as a perfect circle and divided it into 360 equal parts. The 360-degree circle was born, but astronomers needed even more precision to track the planets. So they took a single degree and divided it again by their favorite number, 60. They called this tiny slice a minute of arc. And if they needed to go smaller, they divided that minute by 60 again, creating the second of arc. Wait, minutes and seconds? Yes. When humanity later needed to standardize mechanical clocks, they used the exact same Babylonian astronomical math. Because the Earth rotates exactly 360 degrees in 24 hours, the measurement of space and the measurement of time are forever locked together by the number 60. Armed with this highly divisible math, Babylonian astronomers weren't just recording the past anymore. They were doing something revolutionary. They were looking into the future. They compiled the Enuma Anu Enlil, a massive database of nearly 7,000 celestial omens. By feeding centuries of data into their mathematical models, they realized they could predict exactly when the sky would go dark. The monster eating the sun was no longer a terrifying mystery. It was a mathematical certainty, and they cracked the code to predict it. They discovered the legendary Saros cycle. The universe wasn't magic. It was a giant clock, and humanity had finally figured out how to read it. To understand the Saros cycle, we must look at how eclipses actually work. A solar eclipse happens when the moon perfectly blocks the sun's light from hitting the Earth. Since the moon orbits the Earth every single month, you might wonder, why don't we have a terrifying solar eclipse every time there is a new moon? The answer is simple geometry. The moon's orbital path isn't perfectly flat. It is actually tilted by about 5 degrees compared to Earth's orbit around the sun. Because of this 5-degree tilt, most months the moon's shadow completely misses the Earth, passing harmlessly either too high or too low in the vastness of space. The two orbits only cross at two specific intersection points called the lunar nodes. An eclipse can only happen if the moon hits this exact node during a new moon phase. This is an incredibly complex, three-dimensional dance. So without orbital telescopes, gravity equations, or computers, how could ancient people possibly predict this cosmic coincidence? By writing absolutely every single moon phase down for generations. They recorded hundreds of years of data, hoping a mathematical pattern would eventually reveal itself. And it did. After analyzing centuries of records, the Babylonians found the repeating rhythm hidden in the noise. An incredibly precise cycle emerged. They discovered that eclipses perfectly repeat themselves after a period of exactly 223 synodic months. Translated into our modern calendar, this cycle equals precisely 18 years, 11 days, and 8 hours. This is the famous Saros cycle. If a total solar eclipse happens today, the geometry of the Earth, Sun, and Moon will return to an almost identical position exactly one Saros cycle later. But there is a catch. Notice those extra 8 hours. Because of those 8 hours, the Earth rotates an additional 1/3 of the way around on its axis. This means the next eclipse in the sequence won't happen in the exact same place. The path of totality shifts 120 degrees westward across the globe. Still, recognizing this cosmic rhythm was a monumental leap. Ancient astronomers who understood the Saros cycle possessed unimaginable political power. But Babylon wasn't the only empire playing cosmic mathematics. Deep in the jungles across the ocean, another civilization was obsessively tracking a completely different celestial god. For the ancient Maya, the sun and the moon were incredibly important, but they developed an absolute obsession with a different glowing dot in the sky. It wasn't a star at all. It was the planet Venus, the third brightest object in the sky. And the Maya tracked its complex movement with terrifying accuracy. To see their work, we have to look at the Dresden Codex, one of the few surviving Mayan bark paper books. It is a masterpiece of prehistoric mathematics. Instead of Babylonian cuneiform, the Maya used a unique system of dots and bars. A single dot represents 1, and a horizontal bar represents 5. And while Babylon used base 60, the Maya used a vigesimal, or base 20 system. Essentially, they counted using all 10 fingers and all 10 toes. Using this math, they tracked the complex dance of Venus. Because Venus orbits inside Earth's path, it disappears behind the sun, then reappears as a morning star, then an evening star. The time it takes for Venus to return to the exact same position relative to the sun, as seen from Earth, is called its synodic period. Through centuries of patient, naked-eye observation, the Maya calculated this period to be exactly 584 days. Modern astrophysics, using satellites and computers, measures it at 583.92 days. That means over 5 entire centuries, the Mayan calculation was off by barely 2 hours. It is a level of precision that is frankly hard to wrap your head around. They did this from the middle of a jungle with no optical lenses. But why did they care so much? Because in Mayan culture, astronomy wasn't just science. It was the ultimate tool for organizing society and predicting the future. They used the exact phases of Venus to schedule major political shifts and ceremonial events, a concept modern historians sometimes refer to as Star Wars. To achieve this, they built entire cities as astronomical tools. The Caracol at Chichen Itza is a famous round observatory carefully aligned with the heavens. Its narrow windows are precisely positioned to frame the northern and southern extremes of Venus's path across the horizon. A permanent stone telescope, from Stonehenge to Babylon to the Mayan jungles, early humanity proved one thing: the human mind was the first and greatest astronomical instrument. While the Maya were building pyramids, we must travel to the Australian outback to find the oldest continuous culture on our planet. Indigenous Australians have been observing the night sky and passing down highly accurate astronomical data through oral tradition for over 65,000 years. But they looked at the sky completely differently. Western astronomy focuses on connecting the bright, glowing dots to make stick-figure constellations. Many indigenous cultures did something entirely different. Instead of looking at the light, they focused on the deep, empty darkness between the stars. They mapped the massive clouds of interstellar dust, blocking the light of the Milky Way. The most famous of these is the Emu in the sky. The head of the Emu is the Coalsack Nebula, right next to the Southern Cross. Its long neck and body stretch down through the galactic center. But this wasn't just a pretty picture. It was a precise survival calendar. In April, the rotation of the Earth makes the Emu look like it's running. This running position exactly coincides with the time real terrestrial emus are mating and laying eggs, signaling to the people that it's the perfect time to gather them. Later in the year, around June, the Earth's orbit shifts the Milky Way. The Emu now appears horizontal, sitting flat on the horizon. This horizontal position means the male emus are sitting on the nests, incubating the chicks. The sky was literally telling them, stop collecting eggs, let them hatch. The dark constellations are a brilliant example of using the Earth's natural orbital mechanics as a gigantic, infallible ecological calendar for tens of thousands of years. But they didn't just look at shapes, they also looked at behavior. Indigenous astronomers were masters of observing stellar scintillation, what we call twinkling. Stars twinkle because their light gets bent and distorted by shifting currents in the Earth's atmosphere. By carefully watching how much a star twinkled, they could accurately read high-altitude wind speeds and temperature shifts, allowing them to predict incoming weather changes, storms, and seasonal shifts with incredible accuracy. For 65,000 years, the sky wasn't just a place for gods or myths. It was a flawless, eternal survival manual. You just had to know how to read the dark. We journey to the Mediterranean coast around 130 BCE. Here, an ancient Greek astronomer named Hipparchus is about to make a mind-bending discovery. Hipparchus was meticulously compiling a massive star catalogue. But when he compared his new charts to ancient Babylonian records from centuries earlier, something was completely wrong. The stars were not in the right places. The bright star Spica, for example, had measurably shifted its position relative to the autumn equinox. Did the entire universe magically shift? Or was the platform they were standing on moving? Hipparchus correctly deduced something incredible about our planet. The Earth isn't just spinning perfectly on a fixed axis. It is actually wobbling, very slowly, exactly like a spinning toy top losing its momentum. This subtle cosmic wobble is known as the precession of the equinoxes. It slowly but constantly changes the orientation of Earth's axis relative to the stars. It is an incredibly slow process. Modern astrophysics confirms it takes the Earth 25,772 years to complete one single wobble. Because the axis slowly traces a massive circle in the sky, our North Star actually changes over thousands of years. It isn't permanent. Today, our axis points directly at Polaris, but when the ancient Egyptians were aligning the Great Pyramids, their North Star was a star called Thuban. And if you wait 12,000 years into the distant future, the incredibly bright star Vega will become humanity's new northern guide. Imagine noticing a movement so unbelievably slow that the entire sky only shifts about 1 single degree every 72 years. It is virtually imperceptible. By the way, this wobble is why ancient astrology signs don't match the sky anymore. Because of precession, if you were born a Leo thousands of years ago, the sun was actually in Cancer. Hipparchus realized all of this without a telescope, without ever leaving the ground, and without even knowing that the Earth actually orbited the sun. He did it purely through the power of multi-generational data tracking, comparing his own observations to centuries of Babylonian records. Science building upon science, but this profound geometric logic also led ancient Greek astronomers to a completely different conclusion. A massive cosmic error that would dominate humanity for the next 1500 years. For ancient skywatchers, there was one glaring problem that threatened to break astronomy: the erratic behavior of the planet Mars. While stars moved in perfect circles, Mars would occasionally stop, go backward for weeks, and then go forward again, tracing a strange loop in the sky. Today we know this is an optical illusion caused by Earth passing Mars in orbit. But to ancient observers, the idea of a moving Earth was completely absurd. Think about it. If the Earth is rocketing through space at thousands of miles an hour, why don't you fly backward when you jump? Why doesn't the wind howl constantly? Based entirely on their naked eye data and daily physical experience, concluding that the Earth was the stationary center of the universe was actually highly logical science. Enter Claudius Ptolemy, a brilliant mathematician working in Alexandria, Egypt, around the year 150 CE. Ptolemy needed to create a mathematical model that perfectly predicted where the planets would be, while explaining the weird retrograde loop, all without moving the Earth. His solution was a stroke of absolute geometric genius. He introduced the epicycle, a circle moving along the edge of another circle. Think of it exactly like riding the spinning teacups at a carnival. You are spinning in a small circle, while the entire ride slowly moves you in a giant circle. If you attach Mars to the smaller spinning circle, its path through space perfectly traces out that exact loop-de-loop retrograde shape. The math worked. It was terrifyingly accurate. Ptolemy published his masterwork, the Almagest, predicting planetary positions with stunning precision. To make all the planets fit, the system became a giant, beautiful, overwhelmingly complex machine of intersecting invisible spheres and dozens of epicycles. Because it matched the naked eye observations so perfectly, it was universally accepted as absolute truth. For 15 centuries, nobody seriously questioned it, but as centuries passed and observations got slightly better, the math required to keep Earth at the center became a hopelessly tangled mess. Ptolemy's model was completely wrong, but it was brilliant science for its time. However, a storm was brewing, a revolution that would finally shatter the crystal spheres. For thousands of years, the naked eye was our only window to the universe, until the year 1608 in the Netherlands, when someone put 2 pieces of curved glass inside a tube. The invention of the telescope shattered the ancient worldview almost overnight. When astronomers like Galileo looked up, they saw things that were completely impossible under the old rules. They saw deep, rugged craters and massive mountains on the moon, proving the heavens were not made of perfect, smooth, flawless crystal spheres. They saw 4 tiny moons orbiting the planet Jupiter, proving absolutely that not everything in the universe revolved around the Earth. The geocentric model was dead. Ptolemy's beautiful, incredibly complex machine of epicycles was finally packed away into the boxes of history, replaced by the sun-centered solar system. From there, the telescopic revolution exploded. Newton explained gravity, Einstein bent space-time, and today we use massive orbital telescopes to look back to the dawn of time. But as we marvel at our modern machines, we must never look down on the ancient stargazers. They didn't have our technology, but they had our exact same brains. Stonehenge, the ziggurats, the Mayan pyramids, and the James Webb Space Telescope are all built from the exact same human desire: the desperate need to understand where we are in the dark. They were the first to track the cosmic clockwork, They laid the mathematical foundations of our modern world. They passed the torch. The tools have changed. The clay tablet has become a digital screen. The stone circles have become orbital stations. But the core mission remains exactly the same as it was on that very first, dark, terrifying night so many thousands of years ago. We are a way for the cosmos to know itself. We just had to learn how to open our eyes. If you enjoyed this journey back in time, make sure to hit that subscribe button. The universe is massive, and we have so much more to explore together. Check out our other videos on the mysteries of the cosmos. Until next time, keep looking up.